In 1977, amid the Cold War and the rise of digital technology, humanity launched two spacecraft, Voyager 1 and Voyager 2, into the cosmos. These probes, now the farthest human-made objects from Earth, carry with them not just scientific instruments, but a golden record encoded with the sounds, images, and messages of our planet. Although Voyager 2 launched first on August 20th, 1977, Voyager 1 followed on September 5th and quickly overtook its twin on a faster trajectory toward Jupiter and Saturn. Built by the Jet Propulsion Laboratory and funded by NASA, these spacecraft were designed to take advantage of a rare planetary alignment that occurs once every 175 years. This alignment allowed them to use gravitational assists, a slingshot maneuver using a planet's motion and gravitational pull to travel further and faster than any spacecraft before them. The Voyager's mission capitalized on this celestial opportunity, propelling them across the asteroid belt and on to the outer planets. Voyager 1 reached Jupiter first in March 1979, followed by Voyager 2 in July of the same year. Their flybys of Jupiter provided humanity with its first close-up views of the gas giant and its moons. Images and data relayed back to Earth revealed volcanic activity on Io, Jupiter's moon, fundamentally altering our understanding of geological processes in the solar system. Dr. Linda Morabito, one of the mission's scientists, described the moment she spotted the volcanic plume on Io as one of the most thrilling moments of my career. Following their encounters with Jupiter, both probes continued to Saturn. Voyager 1 arrived in November 1980, and its instruments captured the intricacies of Saturn's rings with unprecedented clarity. The images showed complex structures and spoke patterns, known as spokes, within the rings, stirring both awe and a plethora of scientific questions. Voyager 2's encounter with Saturn in August 1981 gave further insights, including the discovery of new moons. Voyager 1, however, made the critical observations of Titan's thick atmosphere, which redirected its path out of the plane of the solar system and toward interstellar space. Voyager 2, continuing along the ecliptic, went on to make humanity's only close encounters with Uranus in January 1986 and Neptune in August 1989. These flybys revealed Uranus's tilted magnetic field, faint rings and mysterious moons, as well as Neptune's fastest winds in the solar system and the dynamic geysers of its moon Triton. The success of these maneuvers exemplified the ingenuity of their mission trajectory, crafted meticulously by scientists, including Dr. Gary Flandreau and other JPL mission designers. Their calculations and strategic planning laid the groundwork for what became a grand tour of the outer planets, a feat not originally planned when the missions were conceived. With their primary missions accomplished, the Voyagers were poised to delve deeper into the unknown reaches beyond our solar system. The data collected during these early encounters, tens of thousands of images and vast amounts of measurements, has provided the foundation for numerous scientific papers and has spurred ongoing research in planetary science and astrophysics. As Dr. Edward Stone, Voyager's project scientist since 1972, put it, the Voyagers promised great science and delivered on that promise. Thus began the greater voyage of the Voyager probes, not just across our solar system, but into the annals of human achievement. Their journey continues to captivate and inspire, serving as a testament to humanity's reach and our eternal quest for knowledge. From their groundbreaking encounters with the giant planets, these spacecraft transition seamlessly into their current mission, exploring the boundaries of interstellar space and beyond, carrying a golden record bearing the sounds and messages of Earth. As the Voyager probes concluded their planetary rendezvous in the late 1980s, their mission shifted from the exploration of our solar system to the pioneering journey into interstellar space. This transition signified a monumental leap in our understanding of the universe. Voyager 1 on August 25, 2012, crossed the Heliopause, the boundary where the sun's solar wind is halted by the pressure of the interstellar medium. This momentous event marked Voyager 1 as the first human-made object to enter interstellar space, venturing into a realm where no Earth-built machine had gone before. Equipped with instruments capable of measuring cosmic rays, magnetic fields, and plasma waves, the Voyagers began to relay back to Earth data from an environment untouched by the solar wind. The information provided by Voyager 1, especially, offers unprecedented insights into the nature of the space between the stars. Edward Stone, the project scientist for Voyager, noted the increase in cosmic rays and the stark decrease in solar particles as the craft reported conditions from beyond our solar bubble. His accounts, and those of other researchers involved, underline the scientific significance of this new chapter in space exploration, affording astronomers and physicists a clearer view of cosmic phenomena. Voyager 2, not to be outdone, followed its twin into interstellar space on November 5, 2018. Its crossing of the Heliopause added a layer of complexity to our understanding of the interstellar boundary. Measurements from Voyager 2 indicated that the heliosphere's outer layer is both smoother and more complex than previously believed, challenging existing theories about the sun's influence on its surrounding cosmic neighborhood. This kind of data is crucial as it helps refine our models of how stars interact with the galactic environment. Currently, both Voyager probes continue to transmit valuable scientific data back to Earth. Despite their vast distance, over 14 billion miles away, they communicate with NASA's Deep Space Network, sending back observations that challenge our assumptions about the nature of the universe. Originally expected to operate for only a few years, the probes have far exceeded expectations, now potentially running well into the late 2020s as their plutonium power sources diminish but still support limited instrument operation. The endurance of the Voyager probes not only showcases human ingenuity, but also touches on a deeper, more philosophical note. These spacecraft, now distant and solitary, carry the golden record, an ambitious attempt to encapsulate and communicate the essence of Earth and humanity. This record, carrying sounds, music, and greetings in 55 languages, stands as a testament to our diverse yet unified existence, intended for whatever or whoever may find it. As Carl Sagan, who helped assemble the record, poetically noted, "The launching of this bottle into the cosmic ocean says something very hopeful about life on this planet." Thus, as the Voyagers drift farther and deeper into the cosmic sea, they not only further science, but also carry the weighty dreams of the human race, encapsulating our innate need to explore and connect, even across the ineffable vastness of space. As the Voyager probes continue their silent voyage through the void, their journey resonates with a profound message about our quest for knowledge and connection. The conception of the Golden Records, brainchildren of a diverse committee chaired by Carl Sagan in 1977, was an endeavor to embed the story of our world onto a phonograph record, a 12-inch gold-plated copper disc containing about 115 encoded images, along with sounds and music intended to portray the diversity of life and culture on Earth. This record, a time capsule intended for the cosmos, holds greetings in 55 languages, the sounds of whales, a baby crying, human laughter and footsteps, and music ranging from Bach to Chuck Berry. The philosophical implications of these records stretch far into the realms of hope and existential significance. Frank Drake, the creator of the Drake equation, which estimates the number of communicable civilizations in the cosmos, once pointed out that the chances of the records being found are small, yet the act of sending these messages speaks volumes about human hope and our desire for interstellar camaraderie. Renowned astrophysicist Neil deGrasse Tyson reflected on the golden records by saying, "They may never be found, but they could also last 1 billion years, and how many of our other creations on Earth can claim that? The influence of the Voyager missions extends beyond the scientific community into the cultural fabric of society. These spacecraft and their golden records have become symbols of humanity's boundless curiosity and unyielding hope. The records themselves encapsulate a dual message: outwardly, an invitation to the cosmos; inwardly, a mirror reflecting humanity's self-perception at the time of launch. Each note, sound, and image was selected to show the complexity and beauty of life on Earth, yet they also reveal the contradictions and challenges of our existence. As the 21st century progresses, the legacy of the Voyager missions continues to inspire. In 2017, on the 40th anniversary of the Voyager launches, NASA marked the milestone with celebrations and public engagement, highlighting their achievements. This act of looking back while the probes continue their journey underscores our ongoing quest to connect and communicate. The Voyagers have also influenced works like the 1997 film Contact and the music of artists such as Vangelis and Pink Floyd, demonstrating their reach into pop culture and imagination. In concluding, the story of the Voyagers is not just one of technological achievement, but also of a profound human endeavor to connect, to explore, and to understand. They stand as humanity's messengers, carrying the sounds and sights of Earth into the unknown. The golden records carry a message of peace and goodwill, not just to any potential extraterrestrial recipients, but back to us on Earth, reminding us of our shared humanity and the tiny place we occupy in the vast cosmos. As these ghost ships sail into the cosmic ocean, they challenge us to think beyond our planetary boundaries, to envision a future not just on Earth, but among the stars. Launched over 4 decades ago, the Voyager probes continue to be harbingers of humanity's insatiable curiosity and unyielding spirit. As they drift further into the cosmic ocean, beyond the influence of our sun, they remind us of our smallness in the vast universe and our incredible drive to reach beyond our limitations. If you enjoyed this story, hit subscribe for more fascinating historical deep dives every week. Thanks for watching.